Okay, let's begin. I have a story that I want to share with you that relates to the fundamental problems of the economics of water resources or water pollution. How many of you know who Anwar Sadat is? Does anybody know who he is? Who is he, Jake? Or was that Gabe's hand? He was what? Yeah, he was the president. But presidents in Egypt have a tendency to become dictators. I think that's a fair characterization. In any event, he was president and or the authoritative ruler of Egypt from 1970 to 1981. And he was married to a wonderful woman who became the organizer of the UN International Women's Organization after his assassination. The story is related to the Nile River. All of us know, if we have any familiarity at all with the history of Egypt, is that the Nile River is the economic lifeblood of that country and always has been. In any event, while I was at Harvard, we got a grant to do a major study on preserving and maximizing the value of resources, water resources from the Nile River. And there were a team of about 8 of us who went to Cairo. We did a 2-month study. And it was a complicated model, but the Nile River serves 4 major functions in terms of the economic support for that country. 1, the Nile River is the major source of irrigation water for agriculture. 2, it is a major source for recreational activities, boating, fishing. 3, it is the major source of drinking water throughout Egypt. And 4, it's a waste disposal site. People dump waste in the Nile River. There are no regulations. So we did this very straightforward economic analysis trying to price all of those services. So there was a conference in Cairo, and Sadat's wife was in the audience, and afterwards came up and said, I think you should meet with the president. They didn't call him the dictator, they called him the president. And I'm thinking, gee whiz, really did an audience with President Sadat? And she said, yes, he's in our summer home in Alexandria, and I want you to come there and give a presentation to him. You'll have an audience of him and him alone for at least 2 hours. So we took a bus to Alexandria, made what I thought was the most enlightened presentation I've ever made in my whole life. And at the end of 2 hours, he looked at me and he said, you don't understand. And I'm thinking, what do you mean I don't understand? He said, the price of water is 0, it's free. That was the end of the story. And that's what happens with water resources. There's many politicians, many people in societies throughout the global community who believe that water should be free. It should have a price of 0. If it has a price of 0, you're just inviting disaster. You're not going to get to the conclusion or the result that the resource is going to be efficiently managed. So today we want to finish our discussion of water resources looking specifically at pollution. And anybody that's spent, how many people have been to Cairo? A few of you? Have you noticed the Nile River around the city of Cairo? Yes. The water quality isn't what you would hope it would be. Anyway, coming back to water pollution, and the first set of slides try to differentiate the problem that emerges with regard to water quality versus air quality. And the major difference is that the sources of the pollution frequently are not only point sources, but as well non-point sources. And that creates all sorts of scientific problems with regard to fingerprinting the actual mechanism by which the pollution takes place. In contrast, when we're looking at air quality or air pollution, it's generally sourced either with vehicles, mobile sources of pollution, or stationary sources of pollution, smokestacks I've got here, or cars. And any control must recognize, as I mentioned in the last part of our lecture on Tuesday, it has to recognize that there are 2 types of media, namely groundwater versus surface water, which we discussed in the last lecture. There are 2 sources of contamination, point sources versus non-point sources. One source is readily identified and fingerprinted, and the other source isn't. And there are 2 types of pollutants, fund pollutants and stock pollutants, just as we found when we examined air quality. All right, so those are the major dimensions that have to be taken into account in looking at, remember, never lose sight of the following fact. Every time we talk about public policy that serves societal interests is designed to change the incentives that would otherwise exist. And sometimes those policies do so effectively, and sometimes, even though they're well-meaning, they do so and cause harm rather than provide additional support for increased environmental quality, and ideally finding the intersection between economic growth and environmental quality. All right. Now, turning to these 2 types, surface water, we've already mentioned all the different dimensions of surface water. Groundwater is more opaque in the sense of getting measurements about the contaminations that exist and the magnitude of those contaminations. And the 2 sources of contamination, one, the point source. If there's a direct point source, like a drainage pipe or a ditch that conveys the pollutants or contaminants in the surface water, those are quite often easily fingerprinted. Non-point source pollution, particularly runoff from urban uses or from agricultural uses, is much more difficult to identify. All right? The 2 types of pollutants. Fund pollutants, there is some assimilation capacity of, say, groundwater or surface water with respect to diluting what would otherwise be the harm associated with those kind of pollutants. And public policy doesn't have to be nearly as active with regard to controlling fund pollutants as it does with regard to stock pollutants. Here's an example in which there are many power plants throughout the country that actually use coolant water. Once it runs through the plant, it's discharged into nearby watersheds or rivers or streams, and it has an adverse effect on dissolved oxygen. But that's something that can, in fact, is corrected in part, not totally, but in part, through assimilation. Stock pollutants are a far different matter. The major examples of stock pollutants are inorganic chemicals. Probably the leading stock pollutant, at least with regard to surface water, is mercury. And there's disaster stories that have taken place all over the world. One of the most dramatic was a disease that emerged with people suffering from brain damage and or dying from the consumption of fish contaminated by mercury. And there's been formal tests of a number of rivers here in the United States, and in those empirical tests, it turns out that 80% of these 139 rivers show some evidence of contamination. Birth control pills, antidepressants, soaps, perfumes, etc. Now, with regard to public policies, there are 4 types of public policies, 3 of which we've seen again and again when we're looking at different sources of externalities. But in the case of water, there's a 4th policy that has been promoted particularly by a number of environmental groups, and in this policy they argue there should be 0 discharge of chemicals or contaminants either into groundwater or surface water, which is a very, very active policy, right? But you have to stop and ask yourself, is that policy enforceable? Can the government or the public sector effectively control the discharges and hold them at a level of 0? But the other 3 policies, standards, and everything that we talked about with regard to standards here when we're visiting the question of water resources, they're referred to as affluent standards, but they're still standards. And they're command and control. The government comes along and says you must achieve this particular standard. The 2 policies that economists promote with the objective of changing the incentives are corrective taxes, or what's referred to as affluent charges in the case of water, or admission trading of pollutants that otherwise would degrade water quality. Okay, so for the first, the objective of this particular policy is not so much to change the incentive, but just prohibit pollutants from being discharged into surface or groundwater media. And here's an example. EPA has done a study in which they looked at this particular policy and said, okay, what does it cost to remove all of the discharge or pollutants? And it turns out that they found if you removed them all at the time the study was done, would cost $317 billion. However, if you removed 80 to 90% of the pollutants from all industrial and municipal sources, it would only cost $62 million. Now, a quick back-of-the-envelope analysis would say moving from 80 to 90% to 100%, the incremental cost of doing that would be what? You with me? Back of the envelope, what is it? Help me, what is it? Yes, which is the 317 minus the 62. Now, under what conditions would you incur that incremental cost? What would you look to determine whether it is in society's best interest to incur the cost of $255 billion? Yes, Justin? Yeah, exactly. Would you alleviate damages greater than 255, or at least at the margin, the incremental damage reduction? If it were 255, that would make a good decision. Now, it turns out that in all the studies that have been done, they can't come to an incremental damage reduction of 255, and as a result, of course, that policy has never been promoted by the public sector. Now, continuing with any attempts, any mechanisms put in place to attempt to control and implement such a goal, what would actually happen? First of all, it wouldn't be enforceable, because there would be so many incentives on the part of those parties that are responsible for the discharges to, in fact, violate the policy, because they have 2 choices. One, to invest in the control or abatement technology to be able to be in a position for 0 discharges, or to just suffer the penalties. And only suffer the penalties if they're detected, right? So, practically speaking, it's not an operational policy that would, in fact, be effective. And moreover, if there's anything that we discovered in applying the economic principles to environmental externalities or pollution, is that there is an optimal level of pollution that isn't 0. And the reason that that's true is there's a trade-off with respect to the amount of resources that are devoted to controlling pollution versus what's given up with regard to economic activities when you attempt to accomplish a 0 level of pollution. So what the US and many other countries have done, they've turned to standards. And here we find the same problem that's existed when we've looked at other types of pollution. And any attempt to introduce uniform affluent charges will be cost ineffective. And moreover, they will not end up maximizing net benefits over some future horizon. Okay? And what we found in doing empirical studies over the course of the last 40 years is that such policies do not provide the lowest possible cost to achieve a particular target, where the target may be some level of contaminants in either surface or groundwater. Now, since these affluent standards don't achieve either cost effectiveness or economic efficiency, the natural conclusion is to turn to affluent charges, or corrective taxes, which we introduced when we first recognized that there are market failures, and one source of market failure is externalities, and the solution for trying to create the right incentives is put prices on those externalities, and the prices here are the influent charges. Right? This is a table reflecting a number of studies that look at the use of standards, and there are specific pollutants that are covered in surface. This is all really surface water, and here it is a geographic area where these studies were conducted. This is the benchmark, namely a command and control, or standards, not affluent charges, but instead standards, and this is the target in which policies are designed to try to achieve that target, and here is the key message from this particular table, namely what was the cost incurred from a command and control or affluent standards relative to the least cost options that were available. And it's not as dramatic as what we saw in the similar analysis of studies that have been done on air quality, but once again, you see that there are a lot of resources wasted when affluent standards are used rather than incentives associated with pricing the externalities. Okay?
So these options usually like a more market.
Yes. Yeah. Right. This is an economics course, right? All right. Now, in addition to these policies, there are a host of other policies out there. The federal government has introduced subsidies for municipal wastewater treatment, sanitation treatment plants, in large part to remove all the contaminants, particularly from drinking water sources. Now that everybody's drinking bottled water, it's perhaps not as important as it once was. Not everybody, but most people. The nature of this program, it provided the government the federal government provided municipalities, local municipalities, a huge subsidy, and the local municipality only had to pay a small portion of the investment cost. And the municipality then would be responsible for the operation and maintenance costs. Right? You know, given those facts, and those facts alone, if we come back to the fundamental principles that we introduced in the first and second lecture in this course, does this program create the right incentives? Or does it create distorted incentives? Anytime there is a program, it's going to change what otherwise would be the incentives. For example, if there's no federal program, each municipality would have to look at what their own self-interest is and determine the optimal scale of the plant that they should construct. And moreover, determine what the scale of the plant should be given their ongoing operating and maintenance costs of those sanitation facilities. Right? But here, you have an example where one entity, namely the federal government, is prepared to pay for much of the investment costs and let the municipality take care of the operational maintenance costs. So, when you stop and look at that, gee whiz, what are those incentives going to result in if each of them is pursuing their self-interest, and particularly the municipalities? Well, if there's a trade-off between the cost of investment and as I build a more effective plant, I can lower my operational maintenance costs and put all the burden on the federal government with regard to making the investment. So, it shouldn't surprise us that all these municipalities ended up investing and creating these huge monstrosities which were much larger than they needed to be. And the studies that have been done have illustrated that this was a very ineffective program, in large part because of the distortions in incentives. Okay, let's take a concrete example. This is an example that took place in the real world, namely in Rhode Island. Has anybody spent any time in Providence? One of our best universities in the country, Brown University. But Providence, by the way, is not one of our best cities in the country. Pardon? No. Pardon? You know, that's where most of the East Coast Mafia is located, right? It's also they face a number of serious problems with regard to lead-based paint in many of the buildings within that city. But nevertheless, there's an active jewelry industry located in Rhode Island, and in their production process, they, over the years, were discharging high concentration of various inorganic stock pollutants. And the EPA decided that they could not continue to operate unless they introduced standards with pre-treatment standards before they released these contaminants. And the jewelry industry came along and estimated what the cost was going to be on an annual basis to meet those pre-treatment standards specified by EPA. Okay, so the question for you, and you can visit with your neighbor, is it possible to design a policy that would actually lower that cost of $19.3 million that would be more effective? As to say, it would lower the actual cost of meeting those standards. Talk to your neighbor, give it some thought, and I'll call on someone. Pardon? All of them. The 19.3? Yes, yes, yes. Jill, what's the answer? Yes. There was an actual study that came along and introduced permits. And here's a little, this is an admission permit trading system. There was a formal study by two economists at the University of Rhode Island in which they estimated that an admission permit system would have achieved the requirements imposed by EPA at a 40% lower cost. Moreover, if they didn't give the permits, but instead the government of Rhode Island, the state government of Rhode Island, sold the permits, that they estimated that in the market for the sale of those permits, the government could have collected another $5 million in revenues. And the jewelry operations would be certainly better off than they would be facing their estimated cost of plus $19 million. Right? Okay, so let's turn to the problem with regard to point versus non-point pollution control. Non-point sources of pollution are a dramatic and significant problem in the context of water quality. However, the problem is it's very difficult to fingerprint all of the non-point sources. Think about the following example. In the Illinois River watershed that covers Arizona, Oklahoma, Arkansas, there is a lot of poultry operations within that watershed. And poultry, certainly the enterprise is engaged in trying to increase the available amount of meat in the food system, but with that objective comes a fair amount of waste. So what poultry operators were doing would collect all their waste, and now how would they dispose of it? They disposed of it by distributing on various lands surrounding the river or the watershed where various surface water deposits existed. Rains come along and wash that waste into the river and or lakes, and